So, multiple choice questions, aldehydes and ketones. Question 1. How many structural isomers with a molecular formula CH10 all react with tolerance region? So, all you do is, you'd go like this and then see how many times you can, where you can place the double bond O. So, here, and then you could also like do a branch chain. Also here, no, 1, 2, 3, 1, 2, yeah, there, and the final one for the branch one, we should get is answer B, 4 structural isomers of C5H10O reacting with tolerance reagent. Question 2, which alcohol could not be produced by the reduction of aldehyde or ketone? Now, first things first, we need to review like what reduction of aldehyde produces. Reduction of aldehyde produces back to primary alcohol, and reduction of a ketone of an aldehyde, primary alcohol reduction of a ketone to secondary alcohol. So reduction of aldehyde, get back to primary alcohol, reduction of ketone to a secondary alcohol. Which alcohol could not be produced? So therefore it's got to be a tertiary alcohol. Because a primary alcohol could be produced by reduction of aldehyde, secondary alcohol could be produced by reduction of ketones, so therefore we are looking for a tertiary alcohol. So 2,2-dimethyl propane 1-ol, methane, ethane, propane. OH group is on the first carbon, and then we've got 2 methyl groups on the second carbon. And then if we fill in the hydrogens, you can quite clearly see that that's the primary alcohol. It's only attached to one carbon. So that's primary. So I'm just going to write it as like that. So that can be produced. So therefore that's not my answer. Option B, 2-methyl-butane 2-ol, methane, ethane, propane, butane. OH group is on the second carbon, and I've also got a methyl group on the second carbon. And now if I fill in the hydrogens, it is a tertiary alcohol because this carbon that's bonded to this OH is attached to 1, 2, 3 carbons. So that is a tertiary alcohol. Let's just look at the others, just to show how they're not tertiary alcohols. 3-methyl-butane 2-ol, methane, ethane, propane, butane. OH group on the second carbon, methyl group on the third carbon. Fill in the hydrogens, and you can quite clearly see that this is a secondary alcohol, reduction of ketone to secondary alcohols, therefore that can be produced. And if I look at pentane 3-ol, so that's the most convincing, right? Because you're like, oh, the OH group's on the third carbon, so it's going to be tertiary. I guess some students would think like that, including myself. But if we look at pentane 3-ol, methane, ethane, propane, butane, pentane, alcohol group on the third carbon, and I fill in the hydrogens. Remember, there's no methyl groups in this case, like it's not 2-methyl or 3-methyl in this case. Fill in the hydrogens, and you can quite clearly see this carbon bonded to OH is a secondary alcohol bonded to 2 others. So that's a secondary alcohol. Secondary alcohol can be produced by reduction of ketone, and therefore, like I said, the answer is B because that's a tertiary alcohol, and that cannot be produced by the reduction of aldehyde/ketone. Which compound forms a race mixture when reacted with KCN followed by dilute acid? Well, I'm looking for an aldehyde. Aldehydes form a race mixture when reacted with that, or unsymmetrical ketones. Unsymmetrical ketones. Now I can eliminate D because that is, I think, that's an acid anhydride. It's not an aldehyde or a ketone. Yeah, definitely not. Won't form a racemic mixture. And it literally has CH3, CH2 twice, repeating it. So how would it form a racemic mixture? It would be a symmetrical ketone if it was. It's not D anyway, that's the point. So I'm left with C. Well, C, I look at C, that is a symmetrical ketone. Because look, the carbonyl group's in the middle, and then I've got a CH3 on the left hand side, a CH3 on the right hand side. Those cancel out. That is a symmetrical ketone. So therefore that won't form a racemic mixture. Remember, unsymmetrical ketones will form a racemic mixture, or aldehydes. Aldehydes are unsymmetrical ketones. Now I'm left with A and B, and both of them look convincing. However, if I look at A, HCHO, but obviously what actually happens is I've got my carbonyl group here, and I've got a H and a H here. Therefore that is also completely symmetrical ketone. Therefore that is also not my answer. Therefore my answer must be B. And that makes sense because you look, you've got your carbonyl group and you've got your hydrogen here, you've got your CH3 here. Is that symmetrical? No, it's not. You've got a methyl group and a hydrogen here. They're both different. And therefore that's an unsymmetrical ketone, and unsymmetrical ketones or aldehydes form a racemic mixture when reacted with KCN. And then question 4, which alcohol could not be produced by the reduction of aldehyde or ketone? So I think it's not the exact same question. Got different options, maybe 1 or 2 different options. But could not be produced by reduction of aldehyde or ketone. Therefore, what I'm looking for, because reduction of ketone to secondary alcohol, reduction of aldehyde to primary alcohol, I'm looking for a tertiary alcohols because they can't be produced by reduction of aldehyde / ketone. Look at A, methane, ethane, propane, butane, OH groups on the first carbon, methyl groups on the second carbon. I don't really even need to fill in all the hydrogens. I just need to fill in these, and I can quite clearly see that's a primary alcohol. So that can be produced since that is a primary alcohol. If I look at B, 2-methyl-butanol, methane, ethane, propane, butane, OH group on the second carbon, methyl group on the second carbon, I'll fill in the hydrogens of these. I might as well just finish off the whole displayed formula. And I can quite clearly see this carbon bond is OH group. 1, 2, 3. It's a tertiary alcohol, and that's what I was looking for. Tertiary alcohols cannot be produced by reduction of aldehydes / ketones. Therefore, the answer must be B. And that is the end of these multiple choice questions of aldehydes / ketones.